There are two methods that exist for simplifying complex fractions, and this is method one. The steps for simplifying a complex fraction using the first method. The first step is to write both the numerator and denominator as single fractions by adding or subtracting if necessary. The second step then is to divide the numerator by the denominator by multiplying by the reciprocal of the denominator. And the last step is to simplify if possible. So I've got an example written here, x over 4 minus 1/8, and that's all being divided by 6 minus 3 over x. So as the first step says, we need to create a single fraction in the numerator and a single fraction in the denominator in order to begin the process. So just ignoring the denominator completely and focusing only on the numerator, I'm trying to determine the common denominator between a 4 and an 8, which is the least common multiple, and that would be 8. So both fractions here in the numerator need to be converted to something over 8. So x over 4 would have to be multiplied by 2 over 2, because 4 times 2 would make 8. And also 1/8 can just stay as 1/8 because it already has the common denominator of 8 present. So for the denominator, we've got a 6, which is not a fraction, minus 3 over x, which is. So I'm going to turn 6 into 6 over 1, which makes it into a fraction. Anytime you have a term in a complex fraction that's currently not a fraction, just stick it over 1, which is equivalent, and it turns it into a fraction. So we have 6 over 1, and then minus 3 over x. So in order to get a common denominator among these two fractions in the denominator, I'm just ignoring the numerator now. I'm looking at a 1 and an x. The least common denominator would be x. So we've got to think, what do we need to multiply 1 by to convert it to an x? And that would have to be x. So we need to multiply the top and the bottom of the first fraction here by x. And the second fraction already has the x in the denominator, so we don't need to multiply it by anything. So continuing now, x times 2 makes 2x, and 4 times 2 makes 8. So we have 2x over 8 minus 1/8. That's the numerator of the complex fraction. The denominator is going to be 6 times x makes 6x. 1 times x makes x. So the first term is 6x over x in the denominator, and then minus 3 over x. Continuing from there, 2x over 8 minus 1/8 is, as a single fraction, 2x minus 1 all over 8. So I've brought the numerator now to a single term, single fraction, and the denominator now as a single fraction is 6x minus 3 all over x. So step 1 has now been accomplished. The numerator and denominator are both single fractions. The second step says to divide. So a fraction bar simply means divided by. This fraction bar there between the numerator and denominator just simply means divided by. So I'm going to rewrite our complex fraction as a division problem like this. We've got 2x minus 1 over 8, and that's being divided by 6x minus 3 all over x. Okay. Then to divide by a fraction, it's equivalent to multiplying by the reciprocal. So it's now 2x minus 1 all over 8 multiplied by the reciprocal of that second fraction, which is x over 6x minus 3. So to carry out the multiplication, we have to make sure that all numerators and all denominators are factored, and then see if any common factors can be simplified. The only part of this that I see that can be factored is the second denominator, 6x minus 3. We could factor out a 3 from both of those terms. So I'm keeping the first fraction exactly the same, 2x minus 1 all over 8, and I'm going to factor out a 3 from the second denominator. That would leave us with 2x minus 1. So the second denominator factors as 3 times 2x minus 1. To complete the simplification here, notice that the 2x minus 1s are common factors, so they can be reduced. We can just cancel those out and then perform the multiplication, and we are done. So as a single fraction for the result, the numerator is x, and the denominator would be 8 times 3, which is 24. So x over 24 is the simplified result from that initial complex fraction, and this is an example of using method 1 to simplify a complex fraction. Here's another example of simplifying a complex fraction using method 1. I have here 12x over y squared, and that's being divided by 4x over y. So the first step is to make sure that both the numerator and denominator are single fractions, just one term, by adding or subtracting the terms if necessary. Just looking at this, we already have a single term in the numerator, and we've already got a single term in the denominator as well. So we can skip step 1 and go right to step 2, which is to divide the numerator by the denominator by multiplying by the reciprocal of the denominator. So I'll proceed right to that step. This is 12x over y squared, and then divided by the denominator fraction, which is 4x over y. Remember, a fraction bar just represents division, means divided by. So, as I mentioned, division by a fraction is accomplished by multiplying by the reciprocal of that second fraction. So I'm changing the division to multiplication now, and taking the reciprocal of the second fraction. So it's 12x over y squared times y over 4x. So to accomplish the multiplication, we can start reducing right here, or if you prefer, we could write it as one fraction and write it as 12 times x times y all over. We have 4 times x times y squared. From here then, we want to see if there's anything that can be factored in the numerator or the denominator and reduce. The only thing I'm thinking that can be factored would be 12 perhaps as 4 times 3, if that helps you. And we could also write down y times y instead of y squared in the denominator. So if this is something that helps you to reduce properly, you can do this step here. Call 12 4 times 3, and then times x times y. And then in the denominator, we can call the y squared y times y, if this helps you to reduce properly. It's not necessary to go here. But now the 4's we can reduce. 4 divided by 4 is 1. We can cancel those out. And we can cancel out a pair of x's. X divided by x is 1. They reduce. We can also cancel out a pair of y's here. Y divided by y is 1. We can reduce one factor of y from the numerator and denominator. So for the final result, it appears like we have 3 in the numerator and y in the denominator. Okay. This was an example of simplifying a complex fraction using method 1 that already had a single term in the numerator and a single term in the denominator.